Question 5. Which can be both an empirical and molecular formula of a stable compound? I can probably do this by elimination actually and then work out the correct answer. P4O10, well, that's not an empirical formula because it could be simplified to P2O5. NH2, well, you can have NH3 but not NH2. NH2, nitrogen has 3 bonds because it's in group 5 of the periodic table and wants to gain 3 electrons, so it'll have 3 covalent bonds like NH3. It won't have 2. CH3 carbon has 4 bonds, not 3, so CH3 isn't correct. CH2O is correct, so you could have carbon to oxygen double bond and 2 hydrogens. That would be methanal. Question number 6. Which diagram shows the correct bonding and correct polarity in a molecule of oxygen difluoride? Well, we can do some elimination first of all. Fluorine is in group 7, highly electronegative, more electronegative than oxygen. Fluorine is highly electronegative, only wants to gain 1 electron, very small, so would pull that in close to its nucleus. So they're going to have delta minuses, and the oxygen would have a slight delta plus, because fluorine is more electronegative than oxygen. So clearly it's either A or C. What would actually happen? Well, fluorine wants to gain an electron, it's in group 7, and oxygen wants to gain 2 electrons, hence 2 covalent bonds, because it's in group 6. And so they'll both put an electron into the share, so A is correct. C shows that there's some kind of dative or coordinate bond here with fluorine donating the pair of electrons into the covalent bond. Now they both want to gain electrons, so we'll put an electron each into the bond. A is correct. In the early 20th century, the apparatus shown in the diagram is used to investigate atomic structure. When He2 plus particles were fired at a thin sheet of gold, most of the particles detected at point P. In other words, they passed through a gold sheet. What conclusion can be drawn? I think most gold atoms are mainly empty space, so they're not being deflected by the atoms in the gold sheet. However, a small number appeared at point Q, so there was some reflection back. So there must be something in the gold sheet repelling those electrons to send them back again. So these plus 2 plus particles must be repelled by something in the gold sheet. Not many of them come back, so it's mostly empty space, but a few do come back to point Q. So 1 in 8,000 particles must be repelled by something positive charged. A very small part of the gold sheet must be positively charged. So gold atoms have a small positive nucleus. A is your answer.